Hello and welcome to the Engineering the Product Lifecycle programme. My name's Harvey Leach and I'm the lead trainer for the programme. Depending on which course you're following, you may get me for the whole course or you may get to meet one of my colleagues in later modules. We look forward to working with you over the next few sessions. This session is an introduction to the context and the content of the programme and will give you an outline of what's coming up in future sessions. However, before I get to that, let me share with you a little bit about my background. I'm a mechanical engineer by training and spent over 25 years in what was variously British Leyland, Rover Group and BMW Group before leaving to set up as a consultant and trainer in 2004. I started off in research before moving into product development for a number of years. After that, I spent time in a number of production control and strategy roles before moving to spend 2 years in BMW Group headquarters in Munich following the breakup of Rover Group. My final role was at the Mini factory in Oxford, where I was responsible for coordinating the production strategy for the second generation new Mini. A large part of that role involved ensuring that the views of manufacturing were incorporated into the design thinking at the very start of the programme to ensure that some of the things that made the first generation car difficult and expensive to build were designed out at the earliest possible stage. So you could say that I've lived almost every stage of the product life cycle, and for the last 15 years as a trainer and consultant I've worked with a range of organisations to help them deal with some of the product development and production challenges that they've faced. And I hope that the sum of that learning is going to be useful to you as we go through the following sessions. However, that doesn't mean that I always get it right even now, as a recent DIY project reminded me. I decided to make a boxing in unit to tidy up a corner at the office and store some of the rolls of drawing paper and flip charts that I'd got cluttering up a particular corner. I thought about it for a little while, I did a sketch, I measured, I was pretty confident I knew what I was doing, so off I went. However, that confidence was misplaced because 2 hours later I got 2 pieces of wood, the second one of which was short by some margin. I didn't have any more wood left, I didn't want to go out and buy any more, so I scratched my head and thought, yeah, I can make a couple of design changes, it'll be okay, it'll still do the job. The next step was to cut out a couple of pieces using my jigsaw, and I thought, design for manufacture. I need some radiuses on the corners so I can get round with the jigsaw blade. But of course, when I came to cut, I realised that the radiuses I'd put on were too tight, the blade wouldn't go round, and I had to adapt again. Fortunately, those awkward corners weren't going to be seen in the final unit, so I pressed on. It was only when I came to install it later on that I realised that with all the detailed development and all the adjustments I'd had to make meant that it couldn't actually quite get in all of the rolls of paper and flip chart that I'd designed. So pretty much a disaster all round. And I hope that as we go through the next couple of sessions we'll unpack some of the principles and practices that ensure that those sort of difficulties don't happen on a larger scale. So let's dive right in and outline what the rest of the programme looks like. Let me start by giving you an overview of the whole programme. When I talk about product lifecycle, there are actually 2 process streams to consider. The first covers the journey of the product from an initial idea through design and development into production, and then through any changes that happen over its life in the marketplace until it's finally withdrawn. We can refer to this as the time to market process. The second process stream considers the journey of the product through its supply chain, from planning to sourcing materials, parts and sub-assemblies, through production, delivery to customer and support in service all the way to the retirement of that item. We can refer to this as the time to customer process. These 2 processes are heavily interrelated and, as we'll see over the following sessions, decisions made in one area can have a significant impact on another. The various courses in the Product Lifecycle programme consider different aspects of both of these process flows. New product introduction takes us through the evolution of a new product from its initial idea into full production. Design for X or design for manufacturability considers specifically how the requirements of other parts of the product lifecycle are influenced by the design and vice versa to enable us to create products that are better suited for all of their requirements. Traditional design for manufacturability considerations have only extended up until start of production. However, recent years have seen an increasing attention paid to those aspects occurring later in the product lifecycle, commonly referred to as design for X, and this program now explores these other aspects in more detail too. Improving design reviews, which evolved from an in-house program developed for a client who are having particular issues with this key process, takes a deep dive into the principles and practices of enabling all stakeholders to play an effective part in critical review of a design throughout its evolution to produce a better product. Finally, Supply Chain for Engineers is an introduction to supply chain concepts and practices specifically aimed at engineers to help them better understand this key discipline and their role in making it work well. Moving these courses online has given us an opportunity to reorganise them a little for more efficient delivery in bite-sized chunks. The current programme replicates the face-to-face courses with some restructuring, and also gives us the opportunity to introduce later additional modules such as design for service and design for sourcing that are valuable additions to either the design for manufacturability course or the supply chain introduction, yet wouldn't justify an extra full day face-to-face course on their own. Whichever course you're following, you'll start with this core programme. This first session is an introduction that sets the scene for what's to follow. The first virtual classroom session is the Core Ideas unit, which introduces some underpinning principles that are fundamental to this whole subject area and which are repeated in some form in all of the face-to-face courses. In the rest of this session, I'm going to outline how the process of bringing new products to market has evolved over time. We'll then look at some of the external factors impacting product lifecycle management before I invite you to think about how this might affect your organisation ahead of our upcoming face-to-face session. When I started in the car industry, scarily over 40 years ago, it looked very different to how it looks today. British Leyland was considered something of a basket case as the UK faced up to the growing success of Japanese manufacturers. Bringing a new car to market typically took around 7 years or more, a far cry from the 3 years or less that's typical today. A brief look at the evolution of the way products are developed over that time will start to give us some insight into some of the challenges to be faced in developing ways of working that enable effective management of the product life cycle. Going back to those early days, flow of activity used to be sequential. Work in one function would be completed and passed over the wall to the next, flowing smoothly through the process. Except, of course, it didn't, because each subsequent area would find problems with what the previous area had done, and there would be a flow of complaints and requests for changes going back the other way. What I'd like you to do now is reflect on the two questions on the screen. What are the effects of this type of approach? In other words, what does that flow of complaints and change requests lead to? And what other effects are there? And where do you see these in your organisation? I'll give you 2 minutes to complete that activity now. Well, what sort of things did you identify? I'm guessing things like siloed thinking, project delays and extra costs were all in there somewhere. In my industry, things had to change in order for it to survive in the face of increasing competition. So, over time, the way projects were organised began to evolve. Initially, this took the form of more structured handovers between the different areas. So if we could crudely imagine the throw it over the wall approach as a shot putter, and yes, I know it's a bit of a tortuous analogy, but it helps me with what's coming next. This development was more like a relay race. Over time, the overlaps became bigger, with engineers staying involved with projects in a more structured way, all the way through to production. The biggest developments, though, in my experience, came when we were able to involve the manufacturing, engineering and production teams very much earlier in the process, right at the stage of concept design. We can liken this to a rugby game, where various members of the team have different roles, and as the ball is moved up the field, it moves back and forth between team members depending on who's the best person to help it move forward at that time. As a little side note, it's interesting that the ball's got to move back a bit every time it's passed in rugby, just as a handover in product development usually has some time penalty associated with it. You might want to pause the video at this point and just think for a minute about where your organisation sits in this regard. If we look at today's world-leading organisations, they'll typically have ways of working where an awful lot is happening in parallel rather than the siloed sequential process that we started with. This diagram's a pretty poor attempt to visualise that actually, because in reality there's communication across all functions and in many multidisciplinary virtual teams to get things done. From a textbook point of view, this is what we would call concurrent engineering, where the product and the operational processes are developed together. If we're going to use existing processes and manufacturing equipment, then the product must be designed for those. If we're talking new processes and equipment, then we design those alongside the product so that they work well together. Going back a while, this would typically have been mostly manufacturing processes, but today we're increasingly seeing supply chain and other activities also included. Many companies will also involve suppliers and refer to this process as collaborative engineering. We'll explore this concept and how it works in practice in future sessions. Of course, none of this exists in isolation, so it's worth spending a few minutes looking at the context in which our product lifecycle operates. If we look back 400 years, the product lifecycle was much simpler. Very few people had much of anything, and the pace of change was pretty slow. Only the rich could afford to have more than basic things made, and pretty much everything was handmade by craftsmen at some price. Since then, things have evolved at an increasing pace, and while the evolution's been progressive, it's generally characterised as having four main stages. The first industrial revolution, now referred to as Industry 1.0, was the one that changed everything. Water and steam power enabled machines and factories to be built and products made in greater and greater volume. It was only in the early 20th century, though, that the use of electricity and the work of pioneers like Henry Ford brought prices down as they produced well-designed products in high volume. So the start of the mass production era, what's now referred to as Industry 2.0. Of course, at that stage, the products were pretty much essentially all the same, but people didn't mind, as for most, it was the first time they were in their price band. However, that feeling didn't really last long, and people began to want products that were different from their neighbours, as long as they didn't cost too much more. And this drove manufacturers to make increasing variety in their products, although often at the cost of holding lots of inventory to satisfy the growing uncertainty of demand and a loss of competitiveness. The challenge of the latter part of the 20th century and early 21st was how to satisfy this growing demand for individuality and customization, the so-called mass customization or Industry 3.0. The benefits of mass production were increasingly being eroded, and yet customers expected that they would get this increased variety and individualization for similar or lower prices. This drove many Western companies to learn from the experiences of the Japanese, who, through necessity post-World War II, had developed ways to deal with these challenges more effectively. And recent years have seen that trend accelerate, and the level of variety and individualization increased by a range of new technologies extending beyond the physical product, so-called Industry 4.0. Here we see the different elements commonly included within the concept of Industry 4.0. Critical here is not only to think about the separate technologies, but also how they work together to radically change the design options and potential service offerings. So for example, autonomous robots coupled with additive manufacturing could radically change our factory infrastructure in terms of the tools and fixtures it would have. Considering design for manufacture, assembly and service and so on means considering a very different production environment with different constraints, but also many new opportunities. The combination of Internet of Things and big data analytics has opened up whole new opportunities for preventative maintenance regimes and has led to the concept of servitized business models. Augmented reality with simulation has brought us digital twins that both revolutionise the prototype process as well as in-life support and monitoring. And there'll be increasingly so many more opportunities to think about, both in terms of the design process and the products to be designed. The final aspect to consider is the impact of changes in the world around us in what is increasingly being referred to as a VUCA world. For those of you who haven't heard this term, it was originated in the 1990s by the US Army to describe the new reality of waging warfare in places like Afghanistan. It stands for volatility, uncertainty, complexity and ambiguity, which are increasingly important factors as we think about the impact on product lifecycle. So what does that look like? Let's start with the massive demographic changes the world's undergoing. So whether it's population growth, the aging population, millennials making up most of the workforce, or the obesity crisis, who you're designing for is changing. Just think as a trivial example of the design of an aircraft seat in terms of the size and shape, as well as the expectations around the integration of technology. Linked to this are the economic changes we're experiencing. We've seen the rise of China and India both as consumers and as producers. The impact of globalization affects both where products you are designing will be produced and in which markets they're going to be sold. For example, designing a hat for the Chinese market is way different from the US or Europe. Just ask Nike and their launch of a green hat in China. If you don't know this story, then look up the meaning of a green hat in Chinese. Sustainability is also a pressing issue. I heard one story that in simple terms we'll need 2 planets to sustain the same level as consumption of today by 2030. And in the same time horizon, if we don't take any action, then it's predicted by weight there'll be more plastic in the sea than fish. You know, I guess that's one example of our VUCA world to reflect how many of us were thinking about plastic usage in terms of product design and packaging in the same way we do today, even 2 years ago. Perhaps the least said about our political VUCA, the better, but it's clear that with increased trade wars and Brexit once again impacting our trade relations, the products we design and manufacture aren't going to be totally immune from these impacts. And finally, it's not only these radical changes that are part of our challenging context, but also the speed at which they're happening. Remember in 2006, the iPhone, the iPad, Uber, Airbnb didn't even exist. You know, it took 75 years for the telephone to reach 100 million customers. The internet took 7 years, but Instagram only took 2, and Pokemon Go just took a month. As late as 2012, Nokia was the #1 mobile phone manufacturer, and who had even heard of Huawei? And this leads me on to the last factor, technology. Whether it's omni-channel, servitization, digitization, there are some significant changes that are both creating new types of products to be designed, like electric cars, or changing the way they're produced, robotics, additive manufacture, or enabling different ways for us to design and develop products. Think about collaborative tools or digital prototypes. So there's an awful lot for us to consider as we think about how we manage, and as engineers and designers, the role we have to play in the creation and delivery of new products. So there we are. I hope that's given you some useful context and some food for thought. I'll close by telling you a little bit about what's coming up next, and then leave you with a couple of questions to ponder before we get together for our first virtual classroom session. In our first virtual classroom, after we've unpacked your thinking on the questions that follow, we'll be looking at some ideas that, in my view, are fundamental when we come to think about any aspect of the product lifecycle. The value of doing more work up front in projects while there's a lot of design freedom, how we move away from a reactive approach to issues to a more proactive, preventative style, working more collaboratively with all functions involved and engaging them early in the product lifecycle process. We'll also spend some time looking ahead to the content of whichever course you've booked to follow. Our virtual classroom sessions are designed to be highly interactive and to help address your specific issues. With that in mind, in addition to the questions I posed earlier in the session, I'd like you to consider this question and bring your top 3 challenges related to the content of this course with you next time. I'm going to give you 5 minutes now to think about that. Of course, I could have asked you to pause the video for as long as you wanted, or do it after it ended, but you might have been tempted to skip it and do it later. Of course, even now you could fast forward and do the same. However, based on my experience, that never works out so well. So I'd encourage you to focus and use the time set aside now. Off you go. I look forward to meeting you, at least virtually, very soon. If you've got any questions in the meantime, please get in touch. My contact details are coming up on the next slide. Until then, goodbye, and I look forward to seeing you next time.